So welcome to our panel on AI in robotics. So let me ask, quick show of hands, who has interacted with a robot in the past year? Like maybe a delivery bot or even self-driving car, anybody? Ooh, yeah, okay, great, thank you. And who's curious about where all these advancements are taking us? You know, we started seeing those things. Where is it gonna go? Who's curious about it? Yeah, that's why probably you're here. You're in the right place because today we got all three trailblazers who are the forefront of this revolution, and they just might have the answers you're looking for. So let me introduce you to the wizards behind this curtain. It's pretty amazing. So first we have Dennis Azaroff, CEO of ScaleDrive AI. Dennis' journey is marked by his leadership in multi-million-dollar innovation programs at BMW and the founding of ventures at intersection of AI, transportation, and energy. And from working with industry leaders like Lufthansa and Silicon Valley's autonomous driving scale-ups, Dennis has now turned his focus on enhancing robots' ability to reason and interact with the world around them. And next, we have Christian, all the way to the right, CEO and co-founder of Cartken. And Christian's work is transforming last mile delivery and industrial transport through AI-based navigation systems for autonomous robots. And prior to Cartken, he led groundbreaking projects at Google, including the BookBot delivery robots, and honed his expertise in machine learning at Bosch. And finally, we are joined by Ain McKendrick, founder and CEO of Faction. Ain brings a wealth of experience, having led engineering efforts at Starsky Robotics, where he pioneered fully driverless semi-trucks on public roads. He's also a key figure in the streaming revolution as a former senior director at Netflix, and one of the original minds behind the iconic Palm Pilot. So with that, I'll hand it off to Dennis.
Makiko, thanks for the introduction. Ain, Chris, excited to be on the panel with you. You guys created companies that belong to a small circle of autonomous driving companies who, really got to the point to start commercial operations. Can you please introduce the companies, what you do, what your products do, and what pains they solve for the customers, and what are the key to success?
First of all, thanks everybody for attending. Great to be here today. My name is Ain McKendrick. I'm the CEO and founder at Faction. And at Faction, we do driverless light electric vehicles and primarily focused on last mile logistics right now. It's one of the more expensive parts of the supply chain. And so we look to automate those operations where you stop using the car as one size fits all for a lot of operations, and we start to use these smaller vehicles that are right sized to the payload and the mission. And the goal, of course, is to save money for both our customers, who are usually corporations, but then also pass those savings on to consumers. And so these vehicles that we operate are highly automated. They are essentially driving robots that can be assisted by humans on occasion. We call a teleassist operator. And so it is a hybrid system. It's essentially supervised autonomy. But I always like to say that bringing any of us a pizza in a 4,000-pound electric car with 300 miles of battery range is a little bit of overkill. So if we can do it with a driving robot and do it efficiently, it's really where it benefits all of us. And it also reduces congestion in the city centers. And so we've been doing on-road operations since 2022. And this year we actually started doing more expanded operations with partners like Chick-fil-A. We're in Houston, Texas. You can use their application to request a curbside delivery, and we will dispatch a Faction vehicle to deliver your food. We typically get it to you in less than 23 minutes from the time you hit go in the application. And we're looking to expand that with other partners over the next couple of years. But it's a fun category to be operating in right now. And it's stuff that actual consumers get to really use and experience every day.
Hi, I'm Chris. I'm the CEO of Cartken. I'm also very excited to be on the panel here. Thank you. Thanks for attending. Cartken builds autonomous navigation stack for small, slow-moving vehicle, even a number smaller than what one is doing. And they are moving outdoors and indoors. So it's like we are going from building to building, typically. And they are built on like this low-cost sensing in mind, like we don't use LiDARs, everything is camera-based, and that makes like the burrito economy work, but it also helps with a lot of use cases we see in industrial spaces to replace human labor or move human labor to something more useful. In places like pharmaceutical companies, automotive companies, where previously people, little push carts or golf carts, move QA samples across a factory premises or a corporate campuses, and now the robots do that job for them, going really from the lab to the production line and back. Yeah, so we've been around since 2019. Previously, the team has been working on similar project at Google. We have like a few hundred robots now in the field. And we do everything from, as I said, industrial sites, corporate campuses, but also college campus where we do a lot of food delivery, and like some last mile food delivery also, for instance, with Uber in Tokyo. So our robots can also handle very, very busy places with lots of foot traffic. And this is all enabled by like the current generation of AI and computer vision.
Impressive. Thank you so much. We at Scale Drive help companies like Cartken and Faction or other use cases like port automation to improve the robot's ability to understand the context and human behavior. And so our first use case is a robot that moves containers at logistic yards and ports. Can you elaborate more on, we've heard a lot, I guess, in the previous discussions that AI is great, but it's always interesting what pain point do you solve, right, for the customer? What is the value that AI creates for the customer? And you've been in the space for many years, so you've built AI systems before, even before you started your companies. Can you elaborate more on what the pain points you solve for the customers and how does it look like from the ROI perspective?
This is actually a really important part about trying to build these as products. And I'm a little bit of a victim of my time when I was doing consumer electronics prior to getting into vehicles. And you have to build something that a customer can actually use, and they would actually be able to hit the right cost and economics for them to actually deploy it. Many of the customers we deal with, they could care less about our AI level and the technology we use and how it works. For them, it's cost and it's time. And so these have to be products. And so one of the things that we did at Faction when we first started is we realized all in, our vehicle systems had to be $35,000 or less, because then we could amortize the cost of the vehicle over its lifespan and meet the equivalent economics, or actually beat the economics, of having humans drive material around. And so this is really important because it grounds you on what technology choices you can make and what systems you're going to kind of deploy at scale. Because if you can't hit their economics, the customer's not going to work with you. And the other interesting part about this is that every customer is going to have their own KPIs or key performance indicators that they want to have you hit. So looking at curbside delivery, the one that we've been shooting for this last year is what they called 10-10-10. It was 10 minutes to prep an order, 10 minutes to drive an order, and 10 minutes for a customer to retrieve it. You have to get the entire operation done in 30 minutes or less. And so in Faction's case, being an on-road system allows us to move a lot faster, where some of our competitors were trying to use things like bike lanes, but bike lanes were only marginally better than sidewalks. We're trying to do sidewalk robots. So the roads were really the only way you could hit the metrics that the customer was asking for. And our vehicles were much more competitive than people who had built $150,000 plus driving robots because they could never hit the cost curve for the customer. And so this is one of those things where, as much as we get super excited about the technology, and as engineers, we want to make these things really exciting and fun, and we love the intellectual curiosity of working on them, we can't lose sight of the fact that we're actually building a product. And if you want to build a successful business, someone's going to be paying you for that product, and you have to be on the right side of the economics.
Cartken, we have like two different segments. One is like last mile, similarly shorter distances, but like college campuses and somewhere also last mile, like food delivery up to like 2 miles. And that segment is very, very cost driven, right? It's like you basically have to deliver for $3, $4, $5 a delivery. Otherwise, it's like a human can do that too. And college campus, for instance, is an interesting case because you cannot it's at the border where it makes sense for a human to do this, because it's like what a human earns is like at some point is not attractive anymore. But on the other side, students are not willing to pay $5 for food delivery across campus. So that's one segment. Interestingly, like our other segment, it's like cost is also a concern, but it's in the industrial space, it's much more driven by labor shortages. So the typical problem these companies have is there's like one of like use cases, but they're still recurring, like bringing a QA sample from a chemical lab, from the production line to a chemical lab. And there's no dedicated staff. It's literally the technician, or like sometimes even the biotech engineer that is busy for half an hour bringing this over and bringing it back. And it's hard to find bioengineers and technicians to begin with. And so it's really about making the employees they have more productive in the time they are there, and also increasing their ROI with that. But it's really about like increasing the productivity of like the high-skilled staff they have, and that's the problem we solve. And of course, the requirement to us then is to our technology is it's like this is not a demo. It's like it has to work 24/7, right? It's like they rely on the robot to operate in these factories non-stop and without any errors. Because if it stops, it's like, the whole process stumbles and, with the consequences. So it takes some time to build the trust in it, but it's like we have now customers, it's like they're expanding in these sectors, and it's a really interesting space where this new generation of robotics that can operate in less structured environments really changes like how the industry works, and like it's like the next driver for productivity.
So reliable commercial deployment at scale is the key word.
And I'll expand one quick thing, because Chris reminded me of one other factor here too. I was speaking at a small meetup a while back on autonomous vehicle systems, and somebody asked me the question. They said, "What's your biggest technical challenge over the next 12 months?" And I'm sure everybody was expecting me to say something like lane keeping or free space detection. And I said, well, actually, to be honest, it's operational integration with your partners. And Chris and I were even talking beforehand about this a little bit. When you deploy with a customer, are they ready for this? And do they have the back-end systems that you can plug into? And where can you hook in your APIs to have your fleet then be dispatched by these customers? And so you can't lose sight of the fact that not every customer is actually ready for this. And there's also a big heavy lift sometimes to incorporate robot technology into a partner. And that's another really important part for all of us that are trying to do commercial scaling.
Now that we know how to solve customer problems and deploy at scale, Chris, you've been in machine learning research for many years at Google and Bosch. Can you share what are the most exciting AI applications and solutions that you see out there and that you implement in your products?
So, there's a lot of hype about generative AI. We don't use generative AI. Because it's like we, for the most part, still use sort of what's called classical traditional AI. It's like really more, detecting obstacle, detecting people, detecting what's drivable ground, all this kind of stuff. What is interesting though was like AI is actually, and that's like how we integrate is making a big change, is like making our deployments more scalable. And I have to give you a bit of background. Like the way these robots work is you don't just set them out there and they magically start working. No AI does that. You have to actually create a map. So the robots know where everything is, like they know where they're allowed to drive, where they better should not drive because there's like fire lanes or what customers don't want them there. And that's a lot of handcrafting. So it's like on a factory side that takes a week. On like a big college campus that's like 3 by 3 miles, or like a huge neighborhood in Tokyo that takes like a month. Because there's a lot of handcrafting where you need to annotate by humans, like, okay, here's a good place to drive by, here's not, and so on. Where we leverage more and more AI is actually in that process, like making these maps more automated in their generation. Where it's like, okay, the robot may have seen a car that was parked and thinks that's a feature, it can orient themselves. It's like, no, that's a bad idea, so it's like, don't do that. And so it's like the AI learns and makes better suggestions for human reviewers to then approve the maps. So it's like that process gets much faster, and it's super important to make it scalable, because it's like, we have, Waymo's in a similar spot, right? It's like they're expanding very slowly. Like they were in Phoenix for 1.5 years, now they're in San Francisco, but it's not like they're rolling it out in the US, because it's incredibly complicated and labor intensive, and like it needs experts to build these maps, which is the foundation for the robots to automate in. But there is like actually where, right now for us, like these AI tools make the biggest difference. And then just a little bit further out, I think there's like some interesting developments in transformer models and end-to-end learning. We're experimenting with also, they make more general, like they need a little bit less tuning, but they also need more data. So there's a trade-off there, but it's not like you throw a more mighty AI model at something and like magically your problems are solved. It just doesn't work that way, unfortunately.
Ain, something to add?
Yeah, well, you probably saw me nodding a lot because we do a very similar approach to what Cartken does as well. I'll also expand that generation 1 for a lot of autonomy companies, we're trying to do these very expensive high-definition maps where they would throw a LiDAR on the vehicles, they would run around and try to build centimeter-accurate maps of cityscapes. I've heard estimates upwards of $1 billion to launch a new metro area using that approach. And that's why you've seen these rollouts being so slow with the first generation of autonomous systems on the roads. We do a similar approach to it. Chris was explaining with Cartken. We don't use LiDAR. We use cameras, radars, thermal cameras. But we do have to create course maps for every city that we go into and everywhere we operate. And I like to joke with my internal team that we want to pick unfair fights. You want to pick areas where you can deploy the technology and that it's going to work. And so when we start doing last mile logistics, we'll usually do a geofence around a location, so pick 3 to 4 mile radiuses, that you'll get it dialed in and working really well. And then that way, within about 2 to 3 months, you actually have an operational system that you've deployed. It doesn't take you a year to get up and running. At the same time, given that our customers have these desires to do rapid delivery, last mile, 30 minutes or less, that's a perfect radius to operate in. You don't have to map an entire metro area. So it's almost like island hopping between where you're getting paid. And I also highlight that we only drive where we get paid. You don't want to speculatively try to map an entire city and hope that you're going to make money off of it. That's why a few of us were talking about this earlier. Robotaxis are actually one of the worst businesses to go into from an autonomous vehicle standpoint. It's usually the lowest margins with the highest expectations because you're moving humans around. And so that's why I love things like logistics use cases and moving goods. And I think both of our companies have keyed on that, where if you can find a customer willing to pay you for robotic as a service, essentially, and do it highly repetitively, that's a great way to scale and deploy.
Yeah, exciting. And like I said, I think it's a great, you have kind of Waymo who is doing robotaxi, and it's probably the biggest market for robotics, right? But it's also the biggest, spending, right? So you have to invest so many billions of dollars to create a robotaxi versus where you can, achieve a lot and solve a lot of problems and create a lot of value for the customer with specific use cases like you guys do. So my experience, we worked with some of the leading autonomous driving companies who also do robotaxis, and we've learned that while the classical AI, like you said, can solve like 98-99% of cases, there are so-called edge cases or corner cases that are still a challenge, right? And so we are excited at Scale Drive about the idea of using the novel foundational models, because they are not only trained on the a subset of data or small amount of data that is available in form of video for from LiDAR and cameras, but on the entire internet. And so theoretically the intelligence of these systems is much higher than of a classical autonomous driving stack, and we're excited about how we can utilize this intelligence to help solve edge cases and really bring the robotics to the next level, make it more general and scalable. Can you comment on the issue of solving edge cases, and what are the exciting applications that you see utilizing these latest advancements of machine learning and foundational models?
Well, the one thing I'll highlight with the Faction vehicles that we have them today, we have a remote assist system we call teleassist, and this is where if the robot or the vehicle on the road gets into a scenario where it is an edge case, a human can assist that vehicle. Don't picture steering wheels and pedals for teleoperation. That was very 2017 for parking lot demos and doesn't scale. This is very much like being an air traffic controller where they're pressing buttons to authorize behaviors on the robots. Two real important things come out of that. One is you get to keep the robot a lot lighter weight in terms of its technology stack, in terms of being able to do its job. But every time a human assists the vehicle, similar as Chris mentioned, where how you make the humans more efficient or the systems more efficient, that's all training data that we can then use to then feed back into that system and make our human remote operators more efficient. And so the humans essentially are providing the training data so that the teleassist system might suggest a path or an alternative course of action that a human could authorize. So maybe the first time a human assists a vehicle, it might take them about 30 seconds to say, oh, I'm going to do an overtake on a double parked car. The next time they encounter a similar scenario, the system might suggest, would you like to overtake to the left? What that means is instead of spending 30 seconds adjusting a course line, now the human just hits a button for 2 seconds and says done. Because that's really our cost center, it's the human labor. And so I think when we think about scaling these systems up, you need to be very, I think, deliberate about what level of AI you use on the system and where you're going to apply it. So on the edge, on the vehicles, we want lightweight models. We want things that are a little more deterministic. We want things that we can prove to regulators that this is safe and it's going to perform the same way every time. Lane keeping, free space, halting in objects and such. But more of the complex decision making, we want that done either with our human or we'll do that in the cloud, and you can take advantage of heavier weight models up there. And over time, some of this stuff may migrate back down to the vehicles when it makes sense. But taking a hybrid approach and being, I think, very specific about what type of AI and how much you use is really important.
Thanks, Ain. Chris, I have another follow-up question to you. Ain mentioned deterministic and non-deterministic systems. So machine learning system is non-deterministic, right? You have an input and you don't really know what's the output going to be, right? And it's obviously an issue for a robot that can overrun a pedestrian, right? If it does something not safe that you cannot predict, it might cause problems. How do you go about this? And yes, but on the other hand side, machine learning systems and generative AI systems, etc., can improve your efficiency and improve sort of productivity of the robot, right? So there is a trade-off between efficiency and safety. How do you go about it, and what is your take on it?
This is a really difficult question. I think like lots of people struggle with this, and regulator in particular, because an AI model, you cannot really predict the output. And it's like the broader you make this, I mentioned earlier, the end-to-end training, or end-to-end trained models, which basically means you just feed in camera data and out comes a trajectory. There's like no introspection anymore in the middle, where you can say like, oh, here went something wrong, and this is why that happened. And so for autonomous road vehicles, it's like basically a no-go, right? It's like you cannot explain that to a regulator. It's like, well, I have no idea, the system did this. I have no idea why this person got run over, right? So that's hard. And so that's why the traditional stacks for autonomous driving are usually built like in stages, where it's like, okay, you have a people detection, you have obstacle detection, like you create logs where you can say like, oh, here's something that went wrong, or something we haven't seen. It's like, I don't know, people crawling maybe detected as something else instead of like being upright in the first instance. Or something we ran into, it's like, in fall, there was like a lot of wind, and all of a sudden the bike lanes and the pedestrian paths all got covered in leaves, and like you basically couldn't distinguish anything anymore, right? Like it was even hard for a human. And these are the instances where we could look at it and it's like, hey, this thing just really misclassified what's this bike lane and what's a flower bed and what's a pedestrian path. And it's like we could feed it in the training data very targetedly and put it in. And the approach and that's okay, but the approach we take on our side is like we are very safety conscious. We're like the low-level system don't really use AI. We're just like, there's just, okay, I don't know what this is anymore. Like my confidence level dropped, I stop. and then a human operator takes over. And whenever that happens, like we actually create a log that then gets purposely fed back for review and labeling data. And that's the way to go. And also, if like you jump in front of one of our robots, it will just stop, not because it detects you as a human, just because there's a sensor in front of it that says like, hey, something is there, and if I don't slow down, I will hit it, so it's like I slow down, right? So you have to have like these base level safety things that just guarantee that you don't, hit people, obstacles, or whatever it is, or don't drive into the street. But it is a layered system, right? It's like this is like sort of the lowest level of the intelligence was like there's actually not that much of intelligence more reactive, and then you have like a higher level systems that propose plans and predict it, and it tries to execute it, and these are getting better and better, so that the lower level systems have to interfere less and less, and that helps you driving more efficiently, you stop less, you have more drive at higher speeds, and that's usually the progression we're taking there.
Thanks for mentioning that, and this is what I'm excited about, is how to improve the safety efficiency trade-off by utilizing new systems like you can model human behavior, predict the human behavior, and the better you predict, the more confidently can you drive around people, right? The more closer you can drive to the people. And if you operate a 40 tons vehicle like we do, it's important to not get too close, right? And to predict, to have a robust prediction and robust safety concepts in place. As a moderator, I have to ask one question that is, I guess, very important to the audience. I've heard it at every conference in the last couple of months. The humanoid is the hottest sort of idea that is going around, and I know that Chris has been doing research in humanoids before Google. I'm curious about your take on it, and like, let me ask you specifically, how many decades do you think do we still need to deploy the robots like humanoids efficiently, and if we need them at all?
These are both good questions. So it's like, just give you a little bit background. It was like 2008 where was the first hype cycle of humanoids, I would say, and like it feels like we're in the second one now. We worked together with Willow Garage at Bosch, and it's like we make cool videos. It's like robots folding laundry, plugging themselves into the power outlet, and it's funny because you see the same videos again now these days. But this was actually one question when I was doing that. It was two things. Like, okay, how long is this really going to take to go from a video that I can show around at academic conferences and everybody thinks it's cool to an actual product? And two, does this even make sense? And so the first one, I think there are more powerful AI models out there, but there's still very foundational problems that need to be solved. And understanding the environment, like reasoning about how things are. There are some interesting research projects going on, was like, learning from YouTube videos what people do, and these may transfer at some point, but it's still very, very far from like actually being implemented. And then the other problem is humanoid robots. They are very, very complex mechanical machines. Like, we're working here on self-driving vehicles, and that's like sort of mechanically some of the simplest things there are, because there's two outputs, right? It's like speed forward and like turning left, right. That's it. Like a humanoid robot has like all these different joints, like you have like a giant joint space that needs to be coordinated so you don't hit anything, and you need to reason about what makes sense and not, and it's just very, very hard, and it's often unnecessarily complicated. Like the things I always chuckle about is like seeing humanoid robot in a factory space that's bipedal, so it has legs on a completely flat ground. Wheels have been invented for a reason, right? So because they're much simpler, and it's like it doesn't actually solve a problem, right? Like, so one has to be very, very careful if one goes those route, and like these over complex machines, just because they look cool doesn't mean they're the best solution. And I think for most cases, there's probably, in most environments, simpler things than trying to replicate the human body. and trying to build a machine that adapts often also to an environment or other machines that were designed for humans in the first place. Like, it's often easier to just change the factory floor a little bit or like adapt the processes than trying to invent a humanoid robot. So to answer that question, I don't think we're anywhere close to having humanoid robots being a productive part in like actual manufacturing automotive. I think there maybe there were like autonomous driving was like 15 or 20 years ago.
I'll add a comment on there because at Faction, we don't build our vehicles. We work with OEM partners to develop them. So I spent a lot of time walking production lines and meeting with the CEOs of the companies that we're partnering with. And it's a very similar philosophy. They don't need, humanoid robots walking around in those factories. They want the things to be as efficient as possible. And a lot of the robots you will see in automotive manufacturing today, and even just general factories, they're programmed to be very deterministic for what they do, and they want them highly repetitive. They don't want a crazy AI system in there trying to figure out how to mimic a human being and run around. They want predictability, because they don't want any downtime. And if they introduce something that might have some variability and causes downtime on a line, it would make them very upset. And so at the same point, they'll use things with wheels and carts and move things around. That's a great integration for them. But the bipedal robots, I think it'll be interesting to see how they apply them. But I don't necessarily see factory environments getting overly excited about that. It's going to be some sort of maybe specialized applications for it. So even though we get excited about that, but I think one of the, I'm a software engineer by background, but I joke I'm the software guy in the hardware companies because I've always had a hardware-software component. But I also joke that some of the words to watch out for from engineers is when they sit there and they say, "Wouldn't it be cool if?"
Yeah.
And you got to pause for a second. It might be cool, but it might be a little overkill in the technology.
Absolutely. As an engineer, I'm super excited about humanoids, especially growing up with movies like Terminator. It's a super exciting thing, and I do see one reason why it can succeed is because, in my experience, the hardest innovation to commercialize is the one that requires change in infrastructure, right? And our world is built for humans, right? And building a humanoid might be a good idea because if you get it to work, right? If you get it to be generalizable and scalable, then it essentially can do every job without changing any infrastructure. So the billions of dollars that you would spend on building new plants or building new ports or building new roads can be invested in just deploying the robots, right? And with your background in you were the first one to deploy an autonomous truck on the roads without a human behind the wheel. You work for Netflix. You work for. You're now successfully deploying commercially robots on the streets. What is from your perspective the main technological and regulatory challenges that we will face on the road to more autonomy, whether it's on the roads or as a humanoid?
Well, I'd say the number one thing is that you have to be building a product. And so I'm a victim of my time in consumer electronics space because in consumer electronics, you were always going through phase gates before you launched a product to prove that it was ready to throw a switch where you might be making tens of thousands or millions of units. And so you had to make sure it was right and it was ready to go. Same thing in this category. There's a lot of vehicles you might see in robotic systems that you could argue are very much research projects, where when you get into such high level of technology on them or high requirements that they're never going to scale. And so it's a two-part problem where you have to make sure that not only can you find customers for it and that the system is actually scalable, but then you bridge into regulatory, which is can we actually then sell it? And actually can we put it in the market? And so there's been a lot of good work done over the last few years on getting regulatory approvals to run vehicles on public roads. And many states have passed legislation that allows you to do these hybrid systems where as long as you have humans in the loop at some capacity to do remote assistance, that you're free to operate. Level 5, as a lot of people have been calling the ultimate driving systems, doesn't exist. But there are highly automated robot systems that do exist. And if you can work with regulators to explain the difference and they understand what you're doing, they will give you permission to operate. So we've had regulators in California, DMV, CHP, they've been on site, they've seen demonstrations, we show how our systems work. Nevada has actually got some interesting programs where they qualify us as what they call an Advanced Electronic Transportation System. It's AETS. And they even issue a license plate. It's a red license plate that says autonomous on it, and your vehicles receive these types of plates. And so the frameworks are there. I think all of us that are looking to scale, we actually welcome regulation because it sets the ground rules for how you scale and how you deploy. There's been a history of some companies trying to skirt regulators, thinking that they're going to somehow get an edge and maybe deploy faster, but that's usually a mistake. It gets back to the no surprises rule, where if you surprise people in government and you surprise people in general, their first response is that we need to defend against this, or we need to somehow jump on this and regulate it. If you go in early and you say, here's what we do, here's how it works, and you give them an explanation, then you get permission to operate. And so going back a few years to when we did the first completely driverless trucks on public roads in Florida, back at Starsky, we met well in advance of that with Florida DOT, Florida Highway Patrol. We gave them our full test plans. We showed them exactly what we were doing. We did many runs on closed course roads down in Tampa, Florida area, before we even attempted to take a vehicle on the road without a human being on board. And when we did it, we went up to Tallahassee, met with the government officials, explained what we were going to do, and they looked at it and they said, you've been so good about disclosing everything to us on every step of the way. Good luck with your tests. Maybe just call the local 911 center and explain what you're doing in case somebody calls in a runaway truck, and they can tell them it's autonomous. But they were very happy with us to be full disclosure with them. And I think that's the right way to do it.
Transparency is the key, I agree. Chris, you also have experience in different markets like Japan, for example, and Europe. How is it compared to the US in terms of regulation?
There was this joke, the US is leading in software, Asia is leading in hardware, and Europe is leading in regulations. There is something true about that. I'm from Germany originally, so I can speak to that. We have managed to deploy robot under test phase in Germany, but it took a long time, and it's like you need to jump through a lot of hoops. Just generally, like a higher bar to convince people, and like the other problem is not clear who is even responsible for like a small robot that doesn't fit in any predetermined categories. Plus, in Europe, like you have the added problematic. There's a lot of rules about privacy. So even like running a camera in public space, you have to explain why you do it. Even it seems obvious if the robot drives autonomously based on camera data. So there is just more there than the US is. Like I think generally a little bit more liberal about just deploying stuff, and also more proactive and then passing laws or giving a framework and saying like, hey, try it, but make sure you don't hit anything because then you're liable. I actually like the Japanese approach, where it's like they waited a little bit, but they went and for sidewalk robots and specifically put together a very exhaustive testing list where it said like, okay, we think these criteria a robot has to meet, because it's like, here in the US you can effectively teleoperate it in many markets. But that's not really safe, because it's like if your LTE connection drops and the moment you're crossing a street, it's like this thing just sits there. That's not a good behavior generally. So in Japan, for instance, they said like, okay, that case has to be addressed, and they actually tested it. So they made us cross the street and they jammed all LTE networks to prove that it actually works. And this was like, okay, this makes sense, right? It's like we do have an exhaustive list, like you thought about it. And so we got the permission, and it's like, I think we are actually the first ones now since of 2 weeks who has a night driving permit in Japan. That's like a really good approach to regulating these new spaces. So it's like we're not, regulations are a good thing because they guarantee a certain level of safety if they're like well thought through, and if they're the regulator put some thought on it. And you see more and more governments doing that. Similar activities happening in South Korea, and I think other countries will follow, because they all see the benefit of robotics technology, how it helps productivity, how it helps their constituents, and for food delivery or last mile delivery, whatever it is. And nobody wants to be left behind, but it's like, there's just different level of approaches there, and different markets require different attention. Like one challenge in Europe is also, it's like, there's no EU regulation. Like every country has like their same, their own idea about how regulation should look like, needs their own permitting processes. That makes it harder. So yeah, so for last mile, we don't operate in continental Europe anymore, but it's only in the US and Japan now. Okay.
Sounds amazing, thank you. So we have to wrap it up. I have a last question, and then we go over to the audience questions. What one short advice would you give to stakeholders in organizations who are looking to implement and deploy robots? And more specifically, I often get asked, like, what happens to the humans that have done the job before, like instead of the robot, right? So what is your take on it, and what do you recommend?
Well, I think similar to as Chris mentioned earlier about labor, even on the roads, we have a driver shortage in the United States, and the only way you're going to be able to solve this is to make the humans more efficient. And so whether you start to have drivers convert into being teleassist operators where they could supervise 4 to 5, 10 vehicles at a time, that's a way for the human to actually still participate in the new technology, and you can actually pay them a little bit more money now because they're a much more, I'd say, productive employee. And so I think similar to the earlier talk we had at the beginning of the conference, humans shouldn't necessarily be afraid of these technologies. It's a way to kind of increase our efficiency. And I think that's where the future of this is actually going to be beneficial for all of us. So you can make it a win-win-win across the board.
Thank you so much. I've learned a lot for this 45 minutes, and then the reliable, scalable, efficient, all these things together that you're doing with the transparency and working with the international, learning from international market, different markets. I think we're going to make an amazing humanoid maybe one day. So yeah, thank you again.